Hey y'all, so today I got a request to go over rearrangements of carbocations. So anytime a carbocation is formed, that will be in an E1 or an SN1 reaction, in addition reactions where a carbocation might be formed, or in Friedel-Crafts alkylation, there's a possibility that that carbocation will undergo rearrangement. Carbocations are always trying to be as stable as they can possibly be. So they'll shift, if they can, over to a more stable carbocation. So that means if either on the left or the right of the carbocation there's a more stable option, for example, if it's secondary and there's a tertiary on one side, or if it's primary and there's a secondary, the carbocation will literally shift over and trade places with something else so that the carbocation can be stabilized. Okay, so hopefully you can see this. I got kind of a new setup, but here's two situations where this would occur. So I have two carbocations drawn in here. And for these two carbocations, they're both secondary. To the left is primary, so that's not as good, right? Because carbocations definitely want to be as stable as they could possibly be. So if they have resonance, that's the best, but then tertiary, then secondary, then primary. So shifting to the left where there's primary, that doesn't make sense. But here on the right, both of these are either tertiary or this is quaternary. So now remember, this can only happen where either a hydride shifts, so this hydride is a hydrogen with 2 electrons, or the whole methyl group will shift. Anything bigger than that is too big to shift over. So I've drawn in the implied hydrogens, even though technically you don't have to, but for this example, this hydrogen will shift its electrons over, fill in, and the rearranged carbocation will look like this. And it's gone from secondary to tertiary. So secondary is definitely not as good as tertiary, so that's a positive rearrangement, so that will definitely. For the bottom one, there's not a hydrogen that can shift, but a whole methyl group could shift over. And then our rearranged carbocation, there's still 2 methyls that were originally there, but one's gone away, and now we have a carbocation that shifted over. So we went from a secondary to a tertiary. Tertiary is definitely more stable, so that will occur. Now in this example, if we have a carbocation right here, no rearrangement can occur because on the left it's primary, that's not as good as secondary, so that won't happen. And on the right, there's not a methyl or a hydride available. And that's an overview on rearrangements. I always tell my students, if you see a carbocation, you should think, red flag, this could rearrange, I need to check this. So get into that habit. If you see a carbocation being formed, it doesn't matter where it is, check to make sure it doesn't rearrange. Happy studying!